Hello again, pre-calc. So this has taken a little longer to upload than I anticipated. This is your second video. I'm going to try to do shorter clips so you can get them quicker. So at this time, you've wrapped up sine and cosine, and we can pick up again tomorrow if we need to, if you want some more details. Let's go ahead and move along to the next example I'd like to do with you, which is this one. R equals 2 cosecant theta. So now we're going to do some more complicated polar equations that aren't just straightforward petals, and so see what those look like. So at this time, I'd like you to draw y equals 2 cosecant x in rectangular form. And you can do that on Desmos so that you can see it quickly. Okay, so what does that look like on Desmos? And I've already got that ready for us, so let's go ahead to the next slide here. And so what do we have here? Well, remember that cosecant actually is the reciprocal of sine, right? So this is 0, this is 2, this is pi, this is 3 pi over 2, this is 2 pi. I said this is 2, but really that's pi over 2, right? And then we have our asymptotes, which I've put in here as well. And then we're going to go ahead and graph this. So we don't have too many key points here. We only have a few. In fact, I have 2 really. If we look at pi over 2 and look on our polar coordinate plane, notice I put the circles in just so they'd be highlighted a little bit. At pi over 2, our radius is 2. So let's go ahead and move this point over to 2. There's my 2, okay? At pi over 2, it's a radius of 2. Now, if we go to 3 pi over 2, we also see the radius, here's 3 pi over 2, is negative 2. So we have to go the opposite direction, which means we land in the same place. Now, what's happening here between 0 and pi over 2, right? Well, here's 0 and pi over 2, where our radius is really long, and then it gets shorter until it gets to a radius of 2. So what does that mean here? If we just look a little bit of a smidgen to the left of pi over 2, or smaller than pi over 2, that's right over here, a little bit less than pi over 2. So what's happening is we're actually sort of unfolding this asymptote right here. This approach is an asymptote, right? And so this is a nice smooth curve, and if we could measure these at 2, 2.1, 2.2, 2.3, 2.4, this radius is like 2, 2.1, 2.2, and we can extend these points here. Let's go ahead. Oh, I don't want that one. We're going to undo that. So this little piece right here, this point, if I go ahead and make a copy of that, we're actually creating what here? It's actually creating a nice horizontal line. And so this looks very much like this one here, a horizontal line on y equals 2. And if you take a few minutes now and convert this, I'd like you to do that, hit pause, and see that this is actually the line y equals 2. Sometimes it's easier in rectangular form to draw something, but it's just as important to be able to go forwards and backwards from polar to rectangular. I'm going to pause this and then send you another video. We'll do a few little videos since it took so long to upload.